Imagine living in the middle of a desert where summer temperatures can exceed 50 degrees Celsius, where rain falls only a few days each year, where there are no rivers, no natural lakes, and almost no fresh water. Yet every morning, millions of people open their taps and clean fresh water flows without interruption. Hotels, homes, skyscrapers, factories, even giant artificial islands all depend on the same invisible miracle. But here's mystery: where does all this fresh water actually come from? Surely it can't appear out of nowhere. The answer lies just beyond the coastline, in the sea. Every day, gigantic machines pull millions of liters of salty ocean water. Then, using some of the world's most advanced engineering, they remove the salt, the minerals, and even microscopic impurities, transforming undrinkable seawater into crystal clear fresh water. But how can machine separate salt from water? How much energy does it need, and why is this process one of the greatest engineering achievements of the modern world? Today, we are going inside the incredible technology behind desalination plants to discover how Dubai turns the sea into drinking water, and how this engineering marvel keeps an entire city alive. At first, the solution seems simple. If Dubai is surrounded by the sea, why not just drink the seawater? After all, there is more than enough of it. The problem is salt. Every liter of seawater contains around 35 grams of dissolved salt. That may not sound like much, but for the human body, it's far too much. If you drink seawater, your kidneys cannot remove all that salt without using even more fresh water. Instead of hydrating your body, seawater actually makes you lose more water than you gain. The result is severe dehydration. That's why people stranded at sea cannot survive by drinking ocean water. So, before seawater can become safe to drink, almost every grain of salt must be removed. Not only the salt, but also bacteria, viruses, tiny particles, and other dissolved minerals. Only then can the water meet strict drinking standards. This sounds almost impossible because salt is completely mixed with the water. You can't filter it with an ordinary kitchen filter. You need an engineering system powerful enough to separate individual water molecules from dissolved salt ions, and that's exactly what modern desalination plants are designed to do, using advanced technology that operates every second of every day, producing millions of liters of clean, fresh water for an entire city. Now comes the real engineering miracle. Do you separate something completely dissolved in water? The answer isn't boiling, at least not anymore. Most modern desalination plants use a technology called reverse osmosis, or simply IOAT. The heart of the plant are thousands of special membranes. These membranes look ordinary, but they're extraordinary. Each one contains millions of microscopic pores so tiny that only water molecules can pass through. Salt cannot. Before the seawater reaches these membranes, it goes through several stages of cleaning. Large screens remove seaweed, plastic, and debris, then fine filters capture sand, mud, and tiny particles. Only after this cleaning does the water reach the RO system. Now, powerful pumps increase the pressure to incredible levels, often more than 70 times normal atmospheric pressure. This enormous force pushes the seawater against the membranes. Pure water passes through, salt stays behind. The result is two separate streams. One contains clean, fresh water. The other contains highly concentrated salt water known as brine. This process runs day and night without stopping, producing millions of liters of drinking water every single day, all because engineers found a way to separate water molecules from salt using nothing but pressure and one of the most advanced filtration systems ever created. There's just one problem: reverse osmosis needs enormous pressure, and creating that pressure requires a huge amount of energy. Imagine trying to force an entire ocean through millions of microscopic holes every second. That isn't easy. Massive high-pressure pumps work around the clock, generating enough force to push seawater through the RO membranes. Without these pumps, no fresh water would be produced years ago. This process consumed so much electricity that desalination was considered too expensive, but engineers found a smarter solution. Instead of wasting the remaining pressure after filtration, they recover it using devices called energy recovery systems. As the highly pressurized brine leaves the membranes, it still contains a tremendous amount of unused energy. Rather than letting it go to waste, special turbines and pressure exchangers transfer most of that energy back to the incoming seawater. This means the pumps don't have to work as hard, saving a massive amount of electricity. Modern plants can recover more than 90% of the pressure that would otherwise be lost. It's one of the biggest reasons why desalination has become far more efficient than ever before. Today, the challenge isn't just making fresh water, it's making it with the least amount of energy possible, because every drop of clean water depends on smart engineering, not just powerful machines. After the fresh water is separated, one important question remains: what happens to all the salt? It doesn't disappear, it stays inside the leftover concentrated seawater. This liquid is called brine. Brine contains much more salt than normal ocean water. Simply dumping huge amounts back into the sea could harm marine life, because fish, corals, and other creatures cannot survive sudden changes in salinity. That's why modern desalination plants use special outfall systems. Long pipelines carry the brine far away from the shoreline before it's released. It is often mixed with large amounts of seawater, reducing its salt concentration. Powerful diffusers at the end of the pipeline spread the brine over a wide area, helping it mix quickly with the ocean. Engineers also monitor water quality, temperature, and salt levels to reduce the environmental impact. In some places, the salt is even recovered for industrial use, although most plants still return the treated brine to the sea as safely as possible. Producing fresh water is only half the job. Protecting the ocean is just as important, because the goal isn't only to supply millions of people with clean water, it's to do it without damaging the environment. That's why every modern desalination plant is designed not only for efficiency but also for sustainability. Making fresh water is only the beginning. Now it has to reach millions of people across an entire city. The clean water leaving the desalination plant doesn't go directly to your home first. It enters massive storage tanks. These giant reservoirs store millions of liters of drinking water, providing a constant supply even if the plant temporarily stops. Next, powerful pumping stations take over. Huge pumps push the water into an underground network of pipelines. These pipes stretch for hundreds of kilometers, running beneath roads, buildings, factories, hotels, and neighborhoods. Engineers carefully control the water pressure. If the pressure too low, homes on higher floors would receive very little water. If it's too high, pipes could burst. That's why pressure sensors and automated valves work 24 hours a day, continuously adjusting the flow. At the same time, water quality is constantly monitored. Special sensors check purity, temperature, mineral levels, and chlorine concentration. If anything falls outside safe limits, the system immediately alerts engineers. By the time you open a kitchen tap, that water has traveled through one of the world's most advanced water supply systems. A journey that began as salty ocean water and ended as clean, safe drinking water delivered to millions of people every single day. So how does Dubai get fresh water from the sea? The answer isn't magic, it's engineering. Every day, millions of liters of seawater are collected, carefully filtered, forced through microscopic membranes, transformed into clean, safe drinking water. Powerful pumps generate enormous pressure. Energy recovery systems reduce electricity consumption. Advanced sensors monitor every stage of the process, from the moment the seawater enters the plant until the moment fresh water flows from your tap. Meanwhile, engineers carefully manage the leftover brine, protecting marine life while supplying an entire city with one of life's most important resources. Without desalination plants, modern cities like Dubai simply couldn't exist the way they do today, as climate change and population growth increase the demand for fresh water. More countries are turning to this incredible technology because the future may not depend on finding more rivers, it may depend on learning how to use the oceans more intelligently. What was once undrinkable can now sustain millions of lives thanks to innovation, science, and world-class engineering. The next time you drink a glass of water in a desert city, remember it may have begun as seawater and traveled through one of the most advanced engineering systems ever built. If you enjoyed this documentary, don't forget to like, share, and subscribe to RailForge, because here we uncover the incredible engineering behind the machines, technologies, and mega structures that shape our world. Thanks for watching, and we'll see you in the next documentary.